Every day? You want to just judge me over this? It's like, no.
Okay, quiet. No one talk. Silence. Okay, look. Problem 8, definitely one we want to talk about. Here's why. It is a unique problem. I have seen, I've gone through multiple choice tests clear back to 1969. So I've studied 69, 73, 87, 88, 97, 98, 2003, 2008, 2008 sample, 2012, 13, 14, 15, 16, 17, an extra 17 sample, 18, 19. So I've studied a lot of multiple choice tests. I've seen this question once. That's how good they are at coming up with new questions. You won't see it, but the concept that is required to solve the question I've seen many times on one test. So this one is a very high priority question. Please.
Okay, wait, is it using like the min-max theorem? Is that what I'm supposed to use? Or no? I was like, as I was like re-looking at it, I was like, what am I, okay, never mind.
You're fine. Hey, look, listen. Okay, as soon as Carly's correct. As soon as it said the words, which of the following values is greatest, I think min-max.
Gosh darn, if only I could do that yesterday.
No worries. Look, hey, that's your cue. Like that's one thing you should always be picking up from when we talk about problems in classes. What clue am I grabbing first that gets me going? It's that first step that's crucial. Take one step, you'll see the second step. So without pulling up let's look real quick. On your golden notes, okay, the min-max theorem is a huge box because they do ask questions that can get kind of involved. So if you look at this really big box on page 2 of your golden notes, hey, don't talk, please. I can't concentrate when you talk in between. Okay, this is mostly written to help you with FRQs. So when you're doing a multiple choice, you can kind of shortcut it a little bit. Because a lot of this is to make sure you get the justification points on an FRQ. Multiple choice, you just got to get the answer. So the key idea is this. Finding an absolute max requires that we basically identify and then eliminate candidates. So then you have to remember that, okay, the candidates are always the ends and the critical points of whatever we are trying to maximize. Here's where people get mixed up. You can't say the word critical point without saying critical point of what? Critical point alone means nothing. It's got to be critical point of something. So in the problem we're working, right here, they've asked us to find when g of x is greatest. This is which of the following values is greatest. These are all values of g. So I need to find the critical points of g. And I would also be concerned with the endpoints right here. Okay? That's what the min-max theorem starts out with telling you. Those are the points to worry about. Question. Okay, next huge idea on the golden notes is right here. A critical point of g in this case is where g prime is either 0 or undefined. So I know right away I've got to go find g prime. That's how I start the problem. Questions about anything? Please.
I kind of looked at this problem in an entirely different way.
It's okay.
I realized that the integral kind of represents area on the graph. And so I looked at from what time to what time has the greatest area. And then I selected off that. Was that a wrong way of looking at it?
Not at all.
Okay.
No, totally valid in this case. It wouldn't necessarily work in some other cases. So it's good that we're continuing with what we're, this current discussion. But no, that's very valid in this case, for
Okay.
sure.
Cool.
Anybody else? Point for Dylan? Please.
Can you explain what you were saying?
Momentarily.
Okay.
Yep, stay with me. Hey, quiet. Okay. So, I've got to find G prime. Now, even though Dylan found a very valid way to solve the problem without finding G prime, finding G prime is a critical skill. Like, there's just way too many points available to you on other problems, not this one. You don't want to not understand what I'm about to do. Because G is an integral, G prime is therefore the derivative of the integral. On your golden notes, left-hand side, page 1, 8 boxes up from the bottom, is the rule. Okay? As was mentioned a moment ago, if you look there, every time I talk about it, you'll get a better memory of it. Questions? Cool. So I use that rule. And I'm going to get, this one's pretty easy because this upper limit is just x. If the upper limit is something like x squared, the rule becomes a little more important. So this is going to become simply f of x, derivative of x. It's a dx on the bottom because this is x, minus f of negative 2, derivative of negative 2. You can do most of this in your head. You don't have to write it out. I write it out so you don't lose understanding. This is 0, hence this is 0. This is 1, hence pretty easy. G prime is f. Questions? Please.
Can you point to which rule you use from now?
Uh-huh. So go to the left-hand side. Left? Yeah, the left is we say. Count 8 boxes up from the bottom. The 8th box. You see how it says d dx of an integral?
Yeah.
That's the one.
Oh, I see, yeah.
Good question. Point. You good?
Yeah, good.
Okay. Anybody else? Look. So now I remember the min-max theorem. I need to identify where G prime is either 0 or undefined. Think with me, don't watch. Hands up. Where is G prime either 0 or undefined? Hands up. Where is G prime either 0 or undefined? Avery. How many knew it? Point. 2 for Avery. Raise your hand if you know why I just did that. Hands. It's all about the why in this class. Who knows why I did that? Why was it legal? Micah.
Because those are all the places that
Super close. Just change. You've got the right thinking. You've got to adjust the words just a little, otherwise it will cost points on an FRQ. X equal 1 is actually the only critical point of G. However, the maximum of G could occur at a critical point of G or an end point of G. That's what it says here. The absolute max or min of G is always located at a critical or end point. So that's what I did. I circled the critical and the end points. How many knew it? Point. 2 for Michael. Please, Stanley.
Couldn't it also be -3 because of a, would that be considered an endpoint?
Yes, did I not circle that?
You didn't know. Or you did?
Yeah, we're okay. Just making sure. Point. Very good. Okay, now the min-max theorem says, oh, one thing you can do now is just go find those values. So I could just go find, I can do 3 integrals because I have a formula right here. But remember, you don't want to rush on the AP test, but if you can go faster, it's better. You only have 60 minutes. So see if this idea makes any sense to you. I look at F and I go, I don't want to think of this as F. That's G prime. I noticed something really, really valuable about G prime prior to x equal 1. Who sees what I see? Like I see a characteristic of G prime that I find extremely valuable prior to x equal 1. Hands up. There we go. Jake.
It's all positive?
It's all positive. How many saw it? Point. If G prime is positive, hands up. What do I know about G? Come on. G prime is positive, Max. What do I know about G?
It's increasing.
Sweet. Prior to x equal 1, how many knew it? Point.
Yeah.
See, no offense to Dylan, but I'm liking my method better. Because I ain't going to do no integrals. None. I'm going to find the answer without writing anything. Because you can do this in your head. This isn't hard. I just show it so you don't miss the rule. This problem takes no computation. None. Because from x equal negative 3 until x equals 1, what in the is G doing?
Decreasing.
G is increasing. It's going up. After x equal 1, what's G doing? Going down. Collect my points and move on.
That's what I did.
Score! Good work.
If you have, like, in this example, g of x equals to the integral of negative 3 to x. So in this question, you have g of x equals to the integral of negative x of d and to d. So if you have a formula that's equal to the derivative of the original integral of another derivative, like another formula, and one of them's x and one of them's positive, you always assume that it's equal to
Yeah, because the rule will make that happen. Yeah, that'll. Yeah, I always show you the rule because I just don't want you to accidentally fall into the trap of not thinking what you just said. Just automatically thinking that.
So say that it's the other way around, so that G is the derivative of F.